National Exam December 2019 04 BS6 Mechanics of Materials, duration 3 hours. So these are the notes you can go through in this exam. And now we will go and solve those questions in this exam. Question 1. A column consists of a square concrete core of 100 mm multiplied by 100 mm dimension and an outer steel sleeve of 2 mm wall thickness as shown in the figure. So we have this column, this is the column, and this is the cross section, is composed of a steel sleeve and a core concrete. So as per these dimensions, a load of 250 kilonewton is applied to the composite column through rigid steel bearing. So this one is rigid steel bearing plate placed on top of the column. See figure A. So this is figure A. Now the structural steel has an allowable stress of 175 MPa and Young's modulus of 200 gigapascal, while the concrete has an allowable stress of 20 MPa and Young's modulus equal to 16 gigapascal. Determine 1. The forces carried by the concrete core and sleeves. So now the first one, I'll use the concept of transformed section. Now I'll compute the area of concrete. Area of concrete, it is clear to be, so it is like this: 10 multiplied by 10 to the 3 mm squared. A of steel, the steel sleeve, you can compute either way and you will see that it is and it equals to 816 mm squared. Now I'll transform the steel area to concrete. So the total area or equivalent to transformed area, it will be 10 multiplied by 10 to 3 plus 816 multiplied by the modulus of elasticity of steel over the modulus of elasticity of concrete. So it is 200 over 16. And this will equal to 20.20 multiplied by 10 to the 3 mm squared. Now, to compute the stresses, the stress in concrete will be it is 250 kilonewton, the force, multiplied by 10 to 3 to convert to Newton over this one, this area. So it will be Newton over mm squared, it will be megapascal. So the concrete, the stress in concrete, it will be 2, 3, 12, 38 MPa. Okay, now sigma sub s is equal to 250 over 20.2, or it will be 20.2. Okay, the stress in steel, it is this one, it is the same 12.38, but multiplied by what? Multiplied by the ratio, you see, 200 over 16, and this will be, if you calculate sigma s, it will be 154.8 MPa. Now the force in concrete it equals to the stress in concrete, which is this one, multiplied by area of concrete. And this is 12.38 multiplied by 10 multiplied by 10 to the 3. This will give Newton. To convert to kilonewton, we will multiply by 10 to the minus 3. Then F sub C you can get as 123.8 kilonewton. F sub S will be, F sub S is sigma steel multiplied by area steel. So it is sigma steel 154.8 multiplied by area steel multiplied by 10 to the minus 3, and this will give 126.3 kilonewton. So these are the answers: F in concrete and force in concrete and force in steel. You can just check these values. If you add F sub C to the F sub S, it will be 250. Okay, now I also part 2, or the second requirement of this question.